5. Okay, so basically we're going to take this and we're going to convert it into the form x plus something squared plus or minus another number. So that's what we're going to learn how to do. And it's just a process, like a recipe. Do this first, then this, and you've got it. And so I'll just start sort of easy. So step 1. I'm going to modify step 1 with the next one because the next one will have a number in front of the x squared. So we actually have to deal with that first, but this one doesn't. So I'm going to rewrite ax squared plus bx with a space here and then plus c. So we're just rewriting it with a little room between the 6x and the 1. So that's step 1. That's it. Okay, so that would be what you would do first. Then step 2 is to take whatever is in front of the x, so b, take b and divide it by 2, and then square it. So what's b in this example? B equals 6. So we would take 6, divide it by 2, and then square it. 6 divided by 2 is 3. 3 squared is 9. Okay, that's step 2. And then in that space that we left, we're going to add and subtract the 9. In this space, so why can you do that to an equation? We're going to add 9, subtract 9. That was in that space. The rest I just rewrote. So is this still the same equation? Yeah, you can add and subtract. We're just making it work. When we go from, I'm just going to cover this up for a second. You don't need to write it. But when we go from this form, like that, what do? We write this bracket out twice and FOIL it. What we're doing is creating the FOIL, the part that we can factor to get this, or we're creating that FOIL worked out. So this is how you would go backwards. So we've done that, and then step 4 is to factor the first 3 terms and add or subtract the last 2 terms. Because there's 5 terms here. 1, 2, 3, 4, 5. The first 3 can be factored. We're going to factor the first 3 and then add or subtract depending on what the signs are, the last 2. That's what we're going to do. And so what we've done by adding and subtracting that 9 is made this first part a perfect square, so it factors. What does it factor to be? 2 numbers that multiply to give 9 and add to give 6? 3 and 3. And just a note that number, that 3 that's in here, is always the same as what you just found up there. That's that. Okay? So you don't even really need to think about the factoring, but it's there. Minus 9 plus 1? And that's it. Okay? So, what's the vertex? Remember from last class? -3, -8. And you could get the X and Y-intercepts. How do you do that? We're not going to do it. We've done tons of examples last class. We're not going to do another. But we've got both that form and this original form. This is where you would get your X and Y-intercepts up here. is it going to have X-intercepts? Because the vertex is -3, -8.
Yes.
-3, -8 is way down here. It opens up because there's a plus in front of the x squared. You can look up here. There's a plus in front of the x squared. It opens normally, so it is going to cross. So you would have to find them if you're going to graph them. Okay? We're not going to go through and graph, but it would be something like this. Okay, you'd still have to find those if you were doing it. Yep. That's the rule, like the formula to do it. Yeah, so we'll do a couple examples. Okay, so. Okay, so we'll do that b divided by 2 and square it again in each of them. Okay, so this is different. I said that the first one was just going to have, a was 1. That's easy. First step, you just leave the space. That was our first step, was just rewrite it with a space there so that you can add and subtract the number that you're going to find. What you have to do, if there's a number in front of the x squared, so if a is not equal to 1, then we need a new step 1. So step 1 here is going to be factor the 2 out of the first 2 terms. Okay, we don't worry about the c, because what we're going to do is, so we're leaving a space for something here. But before you take your b and divide it by 2, you can't have anything in front of the a. So step 1 is to factor that 2 out. What would we have left? If we take the 2 off of the 2x squared, we have just x squared. And if we divide that by 2, -4. Okay, so we're still leaving that space like we said. Yep.
Why did you factor out the x too?
Because we just want a 1 in front of the x squared. That's what we're doing. Yeah, if you factored out then you're factoring it. Yeah. We want a perfect square here, so we need to leave the x squared. We just take whatever number is in front of the x and factor it out. Okay? And we'll do, the next 2 have a number in front of the x squared to show this first step again. Okay, so this is what your first step would look like. So how is this different than the first step in the first question? In the first question, there was just a 1 in front of the x squared, so I just left a space. I didn't need to do anything special. But for this one, because there's a 2 here, I have to leave a space still, but I need to, so I have to leave a space, but I cannot have anything in front of the x squared, so I have to take it out of both of these. Okay, this 5 we're just add at the end, so it's not important. Okay, step 2. You take b divided by 2 and square it. So what's b now? -4. So -4 divided by 2 and square it. 4. So what do we do with that 4? In that space that we left, we're going to add the 4 and subtract the 4. Always add first and then subtract. So that's step 3. Step 4 is to factor the first 3 terms. So, I'm going to rewrite it. You would not rewrite it all these times, but I want to show you exactly what I do in each step. So what I'm looking at is here, I'm going to factor these. That's a perfect square. Okay, and I'm just going to do that. So what we would have, what would the perfect square be? Two numbers that multiply give 4.
2, 2,
And, yeah, -2. And it's this number right here. Before you square it, always. So this is going to be x minus 2. Okay, so how you would rewrite this, there's a 2 in front. X minus 2 squared is that part. There's still a -4 there. And a 5. I just put the bracket as square so you could see the difference. Whenever I have more than one bracket, I try to make them look different so you can see which ones match up. Okay, so do you follow how I got to this from here? So all I did was factor that, and then I just rewrote the rest. Now it's not quite right yet, but we put the 2 back in. So the next step would be to put the 2 in front of this and with the 4. So that would be 2 x minus 2 squared. 2 and 4 is -8, and then we have the +5. -8 plus 5 is -2. Now, this is way too much work. If you were just given this equation up here, I'll move it back in a second. If you were given this and asked to graph it, you would not complete the square. You don't complete the square unless you need to, because it's a lot of work just to get the vertex. How could we do the vertex without completing the square? X equals minus b over 2a. Fill it in, you get your x, plug it in, you get your y. That's a much quicker way to get this number, right? But like I said, the technique we're learning how to do it because you have to use it for other things, not just graphing parabolas, okay? So it's something you need to know how to do in calculus, but in calculus you don't actually use it to graph parabolas, you use it for other things. So you need to know how to complete the square. The only context in pre-calculus is just graphing parabolas. So, on a test, are you going to just complete the square? No, unless I say, complete the square. Right, so that's what you're looking for to choose to do this. Okay, and you might have to graph it, but again, your vertex you can read off of this, or even if you had to complete the square, you could still get your vertex here and your x, y-intercepts up here, graph it, and then complete the square as a separate thing, and a check for your vertex if you wanted. Okay, so let's do another one. So it doesn't have to have a C, so this is the example for that. So if C is missing, it doesn't really do much difference, because what happened to the 5 in that last question? Let's just take a look. I just kept writing it all the way, and then I just added it in at the end. Right? So with a 0 there, it's really the same amount of work. It's no different. It's just that your intercept is 0, 0. So step 1. We leave a space. There's nowhere really to leave a space because there's no C to move over. And then factor out the 4 because you can't have anything in front of the x squared. I'm leaving a space there for those two numbers that I'm going to add and subtract. Now, how do we find the number that we need to add and subtract? That would be b divided by 2 squared. So b is -2 divided by 2 squared. -1 squared is 1. So what do we do with that 1?
Plus 1 minus 1.
Right, add it and subtract it. So x squared minus 2x plus 1 minus 1. There's no plus c, so we don't even need to worry about it. Now what? Once you add and subtracted, those first three terms make your perfect square. We're going to factor this. And that would factor to x minus 1 squared. And there's still a minus 1 here. Right? The first three terms that factor. Whatever you subtracted is still there. Now what do you think? You have to put the 4 back in. So you put the 4 in front of that, and then with this. So y equals 4, x minus 1 squared, 4 times 1 is minus 4. I do know that one of the intercepts is 0, 0, because whenever there's no c, that's one of them. You plug 0 in, you get 0. So sort of know that right at the beginning. Questions? One more. It's with a negative in front of the x squared. You have to treat it the same as if it had a 4 or a 2 in front of the x squared. You have to factor it out. But people always screw up the ones with a negative in front. So same thing, it's not just a 1 in front of the x squared, so we do, when we leave our space, we have to factor out that negative. So negative x squared plus 2x, leave a space. But we don't want that negative in front, so that's like a negative 1 factored out. You can take it out of all of them, including the c, but I just find leaving that till the very end, less people make a mistake if we don't, just never touch it. Okay, so I just leave it there. And I only ever factor anything out of these two. Okay, so what next? Take b divided by 2 and square it. So that would be negative 2 divided by 2 and square it. 1. X squared minus 2x plus 1 minus 1. Factor this. And I just do it quick. I don't even really look at what the numbers are from here. I just look over and the negative 1. You can double check it, but two numbers that multiply to give 1 and add to give negative 2. Now what? Just like if that were a 4 in front, what did we do up here? Put the 4 in to both. You have to put the negative in front of both. So, negative, negative. So the vertex is 1, negative 2. What else do we know about this one? What's the negative do in front? Flips it. So 1, negative 2 would be here, and it flips, so it's going to be upside down. Is there going to be X-Intercept? No. So if you knew that, that would eliminate you trying to factor to use quadratic equation. What's this point? So this is 1, negative 2. What's this one? Look back at the original. If you put 0 in, what do you get? Negative 3. That's actually all you would need to draw that. You don't need to do anything further, if that were the question. If there's no X-intercepts, there's not much to do. Question? So a negative in front factors out just like as if it was a number. Okay, so we're going to start 2.6. Okay, so for all the graphs, if you see an x squared, you know it's a parabola, and then you say, I need to find the vertex and the intercept to graph it. Every other graph, you need to do the same thing. You need to find the intercept, the vertex, if it has a vertex or an important point, and graph it. What does an absolute value look like? It's a V with straight lines. So these questions are actually identical to doing a parabola. You need a vertex, which is this point, but then you make it sharp, like a V, where a parabola is more rounded. Okay. Now, instead of factoring, because an x squared is where we factor, we use our absolute value stuff we learned to find the intercept. And we're only doing linear ones. So we had done absolute values where there was like an x squared in it, and we're not even graphing those. We're just doing linear stuff. So the graphs look like this. You're going to be given a graph. The vertex is the same as if that was an x squared. So what would it be? Minus a and b. And then we find our x and y intercept. There's no completing the square, it's just given to you in the right form. Right? There's no. So, for example, if we had y equals x plus 4 in absolute value minus 2, we can draw, using transformations, that just means draw the vertex and the v and see if it has x and y intercepts before we start. So the vertex is where? Minus 4, minus 2. So minus 4, minus 2. So if you were to draw a quick graph, minus 4, and it's a v. Is it going to have x-intercepts? Yep. Y-intercepts? Always. So we need to find the x-intercepts and y-intercepts before we can draw it. But just drawing the rough sketch will tell you if you need to do both. Okay, so the y-intercept are the easy ones. We let x equal 0. What's the absolute value of 4? Remember, it's a distance, just 4. Minus 2. 2. X was 0, and we plugged in 0 and found y was 2. Now what about our x-intercept? Good review for the final too, because when we solved for x, we already did these equations. That was all of chapter 1 was solving the x-intercepts basically was all of chapter 1. Every equation we wrote down was finding the x-intercepts. So how do we solve this? Let's move the 2 over. So we have the absolute value of x plus 4 equals 2. How do we solve that? What do we do? There's two options. They are that x plus 4 could be a 2, because you could have a 2, or x plus 4 is negative 2. So x plus 4 is 2, or x plus 4 is negative 2. So we get negative 2, 0, y is 0, or negative 6, 0. Why are we getting two intercepts? Remember, it's just like a parabola, but it's straight lines instead. So you need two, because it's a v, it's going to cross twice. So our vertex always goes first, just like a parabola. 1, 2, 3, 4, 1, 2. Oh, shoot. Here, I'll do it on the next page. I went, well, don't even look. I just did it backwards. Okay, so vertex first. 1, 2, 3, 4. 1, 2. Our X-Intercept, 1, 2. And they should be even on both sides of the middle. Right? They're both 2 away from the center, which is what this was saying, 2 away from that center. And then what was the Y-intercept? 2. And these are straight lines, so you can actually use your ruler. So these should be easier to graph than the parabolas because you don't need to factor these quadratic equations. The vertex is always given because the equation is always written in the right form. So let's do this one. Now I said how to do this last class, but I didn't actually do an example of it. What's the vertex? So do you see there's a problem? I told you last time that it's not always just the negative of that number that's in there, but it has been always so far. I didn't show you an example that wasn't. What did I tell you it actually is? It's not just take whatever number's in there and change the sign. What did I say it actually was? What makes that inside 0? And what makes x plus 4 0 is minus 4, but what makes this 0 is not just negative 1. So you have to be careful. It's what makes this 0. So what does make this equal to 0? Minus 1/2 is the x value of the vertex. That goes for all the graphs, even the parabolas. If in that bracket you had like 2x plus 1, the x value would be negative 1/2. It's whatever makes that 0. And then the y? 5. Okay? So there's our vertex. Now we need our X-intercept. Those are our harder ones. We let y equal 0. What do you think? Any comments on this before I go and do anything further? What's that? Right. You can't have an absolute value to be negative. It's a distance. How would we have known that? What have I been telling you to do all along? As soon as you get your vertex, draw a little rough sketch to see if you need intercepts. If you don't, you might screw up because this is not possible But you could take it out of the bracket and set it equal to -5 and find a number. But it's just not really a point on the graph because you can't have a negative. This is not possible. So what I've been saying to do is, once you get your vertex and you know it's a V, draw a little sketch. So this goes -1/2. Let's make 1 far over. So -1/2 and 5 is up here. Is it going to have X-intercepts? No, so don't try to find them. But does it have a Y-intercept? Yes, it always does. You don't need to think about that. So the Y-intercept is when X equals 0. So 0 plus 1 is 1. Not that it matters, but what that 2 in the bracket in front of the X did was made it wider than if the 2 wasn't there. It would have been a little skinnier. If the 2 had been in front, it would be skinnier. Goes up by 2. So, but that's all you need to know. It doesn't matter what the 2 does. If you have the vertex and your intercept, and we don't need X. Okay, so what would make an absolute value flip and go upside down? What do you think? Where would the negative be? Outside of the absolute value. So an example would be y equals, so an absolute value outside of the, or a negative outside the absolute value will flip it. So you'll know to do your basic graph that goes upside down. What's the vertex of this one? What makes the inside of the absolute value 0? 0. 6. 0, 6, and it flips. Is it going to have intercepts? X-intercepts. Yeah, we already know the Y-intercept, don't we? Because anytime X is 0, that is a Y-intercept. But we need to find them. So we do need X-intercepts. We let Y equal 0. Let's move the absolute value over to make it positive. You could move the 6 over to be negative and then change both signs. But how do we solve this? Should just be easy. Right, X has to be 6 or X has to be -6. That's what the 2 numbers in the bracket would be. So this would be 6, -6. What about this? Does that flip it? It doesn't. It actually flips it. So picture this as a piece of plastic, like I said, right? That you like sort of pick up and can move around. the negative in front of the X but in the bracket actually flips it over. Like if I pick that plastic up, so purple, and on this side, and flipped it over. That's what it does. Is that going to look any different on the graph? No. So with a parabola or a absolute value, if there's a negative inside the bracket, it actually doesn't do anything to the graph. But again, you don't need to know that because you plot your intercepts and your vertex and you've got your graph, as long as those are all right. It's good to know things about it because then you can kind of check your work, see if it makes sense what you're doing. So here, what's the vertex? Remember, it's whatever makes this 0. So 3. Right, 3 minus 3 is 0. And here, negative 1. Draw a rough sketch. 3, negative 1. Is it going to have intercepts? Yeah. I just draw it small because I don't want to go through in the wrong place. But you could draw it big, but you do just might have it wrong. Okay, so we need the X-intercept. There's going to be 2. So that y equals 0. Move the 1 over. So then we say 3 minus x equals 1, or the inside of that, 3 minus x equals negative 1. So x is 2. Or 4. Oh, and write your points right away. So 2 goes with 0, 4 goes with 0, because it was y equals 0 that we were doing. Y-intercept. Absolute value of 3 is 3. So 0, 2. Okay, so let's graph it. Always your vertex first, and the first thing you do is you say it's an absolute value, so it's a V, right? You have to know that right off, what the shape's going to be, because we're going to have a lot of different shapes. So 3 and 1 is here. 3, negative 1. 2 and 4. There it is. One last example. Okay, so this one has a number in front of, we kind of did a number in front, but it was just a negative sign last time, so this one is a little different. So I just want to show you, remind you how to solve something that would have a number in front. Okay, so what's the vertex? Four and negative 8. So 4, negative 8 is here. It opens up because it's a positive in front. So is it going to have intercepts? Yes. So X-intercept. Let y equal 0. Okay, so how would we solve this? Bring the 8 over. And for any of these, you have to isolate that bracket, that important part. So you have to isolate the absolute value. So how do you get rid of the 2 in front of it? Divide both sides by 2. So that would be 4 equals absolute value of x minus 4. Even if it doesn't work out nice, you have to divide it. Okay? So what I'm saying is maybe that would be a fraction, and that's still okay. So we have this, and then we would say x minus 4 equals 4, or x minus 4 equals negative 4. Okay? The inside equals either positive 4 or negative 4. So x equals 4 plus 4, minus 4 plus 4. What's this?
Right.
Yeah, and it's the X-intercept, but it's also Y-intercept. So if you went to find the Y-intercept, or maybe you're doing the Y-intercept first because they're easier, you should find that same point. So 2, absolute value of negative 4 is 4. So 8 minus 8 is 0. Okay, so absolute value doesn't matter if it's negative or positive inside, it makes it positive, just the distance. Alright, so we'll graph this. 4 and 8. Flip it now by 2. So minus 2, minus 4, minus 6, minus 8. Okay, so 4 minus 8. 8, 0, and 0, 0. There we go. So if I had done the scale the same, that would have been farther down, it would be skinnier. Okay, so we're done absolute values, and we have to do cubes, square root, cube root, fractions. Those are what we're doing in the next 2 classes.